Hi, my name is Zach, and you're watching Math Houston on YouTube.
Okay, this is a short video on special triangles filmed in front of a live studio audience in Portable 4 at Canterbury High School. Alright, so we have the first special triangle is a 1, 1, root 2 triangle with 45-degree angles. And the way we get this root 2 is by using Pythagorean theorem from the 1 and the 1. And you'd end up with root 2 as the length of this side. We can do the same triangle using radians. Instead of 45, we put the equivalent angle in radians of pi over 4. The next triangle is a little harder to remember, so I start off with an equilateral triangle with side lengths of 2. That makes the angles inside of it each 60 degrees. And if I cut that in half, I just draw a line down the middle here. It's a very funny triangle. The audience loves this. Okay? If I cut that in half, then this side length here is 1. This side's still 2. And that angle would then be 30. So I have a 60, 30, 90 triangle. So if I start off with the triangle, equilateral, side lengths 2, I can cut it in half and get the 60, 30, 90 triangle. And this side here, using Pythagorean theorem, you get as root 3. And the same thing, so the same triangle, but using radians, would make the same side lengths. Okay. But instead of 60 degrees, I would have, anybody want to say?
30.
What?
Instead of 60 degrees, this would be?
Pi over 3 radians.
Very good, class. Now, what about this angle up here? Instead of 30 degrees, that would be?
Pi over 6.
Pi over 6. Excellent. And now, when we go to use these triangles in the future, when we go to make the trig graphs, we can take a triangle that is similar to each one of these. We'll want to make the radius equal to 1. So the way you'd make the radius equal to 1 on this one is you'd divide each side by root 2. So you'd have 1, 1 over root 2, and 1 over root 2. And for this one you'd have 1, 1/2, and root 3 over 2. Okay, so that's what we're going to use when we go to draw the graphs. See ya next time.